Students, welcome to the Yupp Master. Today we are going to deal the important topic, that is regarding to reflection, refraction of light and total internal reflection and critical angle also. While you are going to solve the problem, what you can see, you can read the 4 or 5 lines problem, what you think about the problem, how you can solve the problem. So, you are going to deal the topic with some well crafted diagram or animated video. Today let us take that the animated video and well crafted diagram, then you can easily grasp the information and you can create that one idea to solve the problem. So, have the look. We are going to take that reflection, refraction of light and total internal reflection, IIT mains level problems. Now, you can go for, they will give the some application oriented problems and they will take the two concepts, they are combined in one problem, just you can see that. Now, we are going to talk about that. Commonly they are asking the time taken by the light rays to travel in a one medium. So, what is the time taken by the light to travel in the glass medium? It is in the order of nanoseconds. If you are going to take the thickness is in the order of mm, right. So, how you can understood that problem, please take that. We are going to have the two media. First one is, yes, you can take, this is the first one, this is the second one. Here you are going to have the one problem, that is the time taken by the light to travel a particular distance in medium 2 or in medium 1. They will ask the question, just to, you have to see that this is that the light is refracted, it has been, angle of incidence is I and angle of refraction is R. Now, here we would like to take that this is the thickness what we are having that, right, alright. Now, we would like to take that this is the normal, with respect to the normal we can guess the angle of incidence and angle of refraction. Next, you can take that medium 1 and medium 2, this is the refracted ray, this is the thickness. Let us assume d be the distance travelled by the light in the medium 2, right. Now, what type of problems that they are going to ask, that you know very well about that, please you can take that time taken by light to travel d distance. This is the question, we are going to solve this problem. Now, you can take that, you know, speed is equal to distance distance by time. At the time you can take that d by speed. Yes. So, you are going to solve the problem speed. Yes. You can take that speed of light in the medium 2, let us assume in any medium, speed of light in medium, that is it is going to be c by mu, yes, c by mu, this is the one. you can easily find out that, yeah, you will take that this is the refractive index, this is the speed of light, right. Now, you are going to take that, yeah, if you are going to take that the time taken by the light ray to travel a distance of t, it can be easily identified that the help of this problem we will solve this one. Now, let us go for problems what they are going to give that, yeah. Yes, the time taken by the sunlight to pass through a window of thickness 4 mm whose refractive index is 3/2. Yes, you can get this, yeah, you are having that options. Let us see later after solving the problem we can look into that matter of refractive index, right. Now, you can take that given data thickness that is thickness is nothing but distance travelled, that is 4 mm, you can take that d, all right. Now, refractive index mu is equal to 3/2, it is very clear. Next, what you are going to take that time is equal to time taken by the light to travel the 4 mm thickness in the window. Generally, you are going to take that windows, they are going to make up with Crookes glass and silica carbide glass, different glasses are there, just you can look, yeah. If you are going to solve this problem, no, yeah, we will take that, yeah, speed is equal to distance by time, you know very well about this is a general formula. Therefore, time is equal to distance by speed, all right. Yeah, speed of light in material, that is very clear. Now, you have to follow this one, dear, you can take that, this is the case. Therefore, t is equal to d by speed of light, that is v, speed of light in that material. You are going to solve this problem, all right. Now, you can easily substitute, get this value. So, you have to calculate that v is equal to mu by, you can take that, yeah, if you are going to look into that matter, if they have given the speed of light in that material, it is okay, otherwise you have to calculate, right, yeah, easily you can find out that, right. Generally, you can solve this problem, mu is equal to c by v, v is equal to c by mu, that is equal to 3 into 10 to the power of 8 meter per second by, what is that refractive index, that is 3/2. So, you can have the value, that is v is equal to 2 into 10 to the power of 8 meter per second. Already you have been obtained the value, this, it is very clear. Now, you can solve the problem by substituting this one. Therefore, time taken t is equal to d by v, it should be equal to, yeah, 4 mm by 2 into 10 to the power of 8 meter per second. So, you are having the different units, just you have the conversion, that is very clear. 4 into, you will get that, just you have the separation, you can write down that conversion very well. Yes, 1 mm, that is equal to 10 centimeter, just you can take that, yeah, that is equal to 10 power 3. Directly you can write down here. You are going to get that express this value, that is you will take that 4 into, you will take that 10 power minus 3 meter, just you will write down 10 power minus 3 by 2 into 10 to the power of 8 meter per second. You are going to get that 2 into 10 power minus 3 into 10 power minus 8 meter. This is meter. Yeah, you have to get the cancellation. Yeah, it is a cancelled, right. 2 into 10 power minus 11 seconds. Just we have to take that. It is case. Now you can see the answers. Yeah, 2 into 10 to the power of 4 minus 11 seconds. If they have given the speed of light in that material, we can easily find out that, but they have not given, simply they have given the distance travelled by the light in that material. So you can easily find out that conversion also, you can do that, yeah, right. Now it's very simple. You can express in nanoseconds also. Sometimes they will give the answer in the nanoseconds. That is 2 into 10 to the power of minus 2 into 10 to the power of minus 9 seconds. So in that place, you can substitute 2 into 10 to the power of minus 2 nanosecond. Yes, otherwise you can write down 0.02 nanoseconds. All right, it is very clear. We are having that different method to solve the problem. In simple shortcut method, directly you will take that speed of light in that material by dividing the C with refractive index of that material, simply you will get that. So finally we are going to solve the problem detailedly. Now here we are going to take that 1 mm, it is 10 power minus 1 centimeter, 1 cm, it is equal to 10 to the power of minus 2 meter. So you will take that totally 10 power minus 3 meter, therefore 1 mm, this is the conversion. You can take this one, numerator and denominator, you will cancel the meter and you will get that second. So time taken by the light to travel the distance of 4 mm thickness of window thickness, that is 0.02 nanoseconds or 2 into 10 to the power of minus 11 seconds. It is very clear. All right. Now let us go for another one. So we are going to take that refraction of light frequency remains same, all very good. So you know very well about that refraction. Yeah, due to the refraction there exists a change in speed of light, wavelength, but the frequency remains same. Yeah, refraction of light. Yes. So we are going to take that, it's very clear. You will take that light has been incidented, it is very clear. Now you are going to take that, it is a incidented light ray and refracted light ray. Now you are going to take that refraction of light is the phenomenon which is related to medium 1 and 2, whereas the reflection only for one medium, it is limited to one medium. All right. Now whenever light enters from one medium to another medium, which are having the different density and their refractive indices also different, at that time what happened, they will change, the light is going to change the direction. So with respect to the normal, sometimes it is going towards the normal, sometimes it is moving away from the normal, very clear. But do you know, light is a form of wave. Light is in the form of wave, is a form of wave. So if you are going to get the light incidented, it is going to be emitted in the form of wave, right. That indicates the direction it travels in the straight line path, unless until it has been interfered by the another material. Let us see what happened. You are going to take that is light is incidented in this way, okay. It has been refracted, okay. That is medium 1 and 2, you will identify that this is V1, V2, lambda 1, lambda 2, but you will take that nu and nu. The number of oscillations made by that light wave per 1 second, they are same, remains same. Number of oscillations made in the first medium, in the second medium also the number of oscillations made are equal, all right. But what is the change? There exists a change in the speed and there exists a change in the wavelength, you know very well about that. Yes, you know V is equal to nu lambda. So V changes, lambda also changes, lambda is also going to be changed, very clear. At the same time, if you are going to talk about that frequency, nu remains, frequency remains same, remains same. It is very clear. Now what is the use of this diagram? To narrate that frequency and it remains same. It has been shown that the number of oscillations made in 1 second, they are going to be same, and due to the change in the speed, we will confirm lambda is also going to be changed. That, so if you are going to take that some last bit, what we are going to apply, it is very clear. Therefore mu 1 by mu 2 is equal to C by V1 by, you will take that it is very clear, C by V2, that is equal to V2 by V1, all right. Now you will get this one, nu lambda 2 by nu lambda 1, right. This is the entire relation to solve the problems, Suppose if you are going to take that sin C, yeah, is equal to 1 by mu, that is, you will confirm that this is also, yeah. Sometimes if there is the medium of refractive index is mu 1 for that first medium and second medium is mu 2. Instead of air we have taken one medium, we can write down this formula, that is mu 2 by mu 1. So sin C is equal to mu 2 by mu 1, very clear. So C is equal to sin inverse mu 2 by mu 1, very clear. We are going to solve this, we are going to get that relations, all right. Now please take that, yeah, this is very important relation. keep in mind to solve the problems. If they wants to know about wavelength, critical angle, refractive index and the speed, whatever you can calculate by knowing the relations, all these relations are very, very important and useful also. Please keep in mind, right. So, what we are having that relation sin z, critical angle also we can calculate, it is not a matter, and you will get that lambda 1 and lambda 2, it is going to be yeah, you will get these values. And let us go for another one, the problems related to this topic. Yes. So, when a light ray is refracted from one medium to another one, okay, right, the wavelength changes from 6000 angstrom to 4000 angstrom. The critical angle for the interface, yeah, you know very well about that, it is clear. Yes, if you are going to incident that, you will get that. Yeah, if you are going to get that, this is theta I, let us assume this is theta I, this is theta R. So, when you are going to take that, you have been incidented the light rays, they will refract, but at this is theta I is equal to theta C. In this case, it is going to be theta I is not equal to theta C, it is very clear. We are going to know about this one, theta I is not equal to theta C, that is theta I is going to be less than that of theta C, right. So, it is very clear, it has been refracted, but what do you mean about that critical angle? It is the angle of incidence at which the angle of refraction becomes 90 degrees, very clear. Critical angle is nothing but angle of incidence. At a particular incidence, you will get that angle of refraction is 90 degrees, all right. Now, you are going to solve this problem, yeah. Now, you can take this, yeah, theta C at theta I is equal to theta C, theta R is equal to 90 degrees, this is very, very clear. Now, you are applying that, you are applying the Snell's law and you can solve the problem for that, right. You know very well about that, mu 1 sin theta I is equal to mu 2 sin theta 2, all right. So, theta 1 is equal to theta C, then theta 2 is equal to 90 degrees. Yeah, this is nothing but theta R, what we are going to take that, please take that value. Therefore, mu 1 sin theta C is equal to mu 2 sin 90 degrees, all right. Therefore, sin theta C is equal to mu 2 by mu 1 into 1. So, theta C is equal to sin inverse mu 2 by mu 1. Yeah, you have to take this one, sin inverse mu 2 by mu 1. Now, in this problem you are going to find out the critical angle. For the interface, you are going to get this is the interface, let us assume. But you have been obtained the relation in terms of mu 2 and mu 1, all right. Now, you can take that given data, that is now you are going to substitute that relations, knowing relations. Yes, we are going to take that given data, that is light is refracted from one medium to another medium, the wavelength changes from, yes, that is 6000 angstrom units here. This is 4000 angstrom units. We are going to get this one. Yes, you can identify. Yeah, it was 6000 angstrom units. This was 4000 angstrom units. All right. Now you are going to get this one. Therefore, sin theta c is equal to sin inverse mu 2 by mu 1. Right. Now you can take that theta c is equal to sin inverse, you will take that, yeah, that is you can identify that lambda mu, just you will take that mu 2 by mu 1 is equal to c by v 2 c by v 1, that is v 1 by v 2, that is equal to lambda 1 by lambda 2. Just you will find out this one. By knowing this relation, we can solve the problem. Right. Now, if you are going to get this, yeah, that is, you will find out, therefore, theta c is equal to sin inverse lambda 2 by lambda 1. You will take this problem. Just you will get this sin inverse. What about that? 4000 by 6000 angstrom units. You get this. Now you can cancel the terms. That is sin inverse 2 by 3. Yes, this is the answer. We can easily find out that. This is a simple problem, but by knowing the relation between the critical angle and the refractive index, we can easily solve that. Right. Okay, let us go for another one. Yeah. Here in this problem, they are going to ask that a glass slab of thickness is 4 centimeter, let us assume. If it is going to be allowing the light to travel from glass to water with the same frequency, and it has been travelled the distance of 5 centimeter by the same monochromatic light, if the refractive index of the water is 4 by 3, then refractive index of glass. Very simple, we are going to take this problem, easily we will solve that. Light enters from that is water, what we have taken, yeah, glass, they have given that. First one is glass, second one is water. What they have given, that you can get the diagram. After getting the diagram, you can solve the problem very easily. So, light is allowed to enter. Yes, you are going to get this one. Yeah, generally if you are going to take this, glass is 1.3 and you can take this one. Let us assume, yeah, its thickness is going to be 5 centimeter. Its glass thickness is 5 centimeter. this is of 4 centimeter, this is of 5 centimeter. This is water and this is glass. This is glass and water. It is very clear. What they are asking? They are asking to get the refractive index of that glass material. That is very, very clear. Now, if you are going to take that, yeah, as compared to glass and water, its refractive index is going to be more. That is, you will find out that light enters from rarer to denser. Rarer to denser, yeah, if you are going to take that just one line, just normal, it moves. But the main thing is you have to calculate that refractive index of that glass, very clear. Now, you know that is light enters from glass to water. Now, you can start the problem mu g by mu w, it is very clear. You can take that, you can take the problem easily solving that matter. Yeah, you know very well about that, C by Vg, C by Vw, that implies, yeah, Vw by Vg, all right. Now, you are going to take that Vw, it is going to take that, yeah, this is, it is going to be 5 by T, let us assume 5 by T, this is, yeah. Now, you will take that Vg is equal to 4 by T, let us assume, right. T is the time and D is the distance what it has been travelled. Therefore, we can substitute 5 by T, let us assume T1 and T2 both are going to be equal. So, we can take that T and 4 by T, it is very clear we are going to have that value. Now, you can cancel the term, therefore, mu g by mu w is equal to 5 by 4, this is the first one. Already they have given mu w, so you can change the equation like that. Therefore, mu w by mu g is equal to, yeah, you will get that 4 by 5. It is very clear. Now, you can substitute easily, you will get this. Just you will get this. We can use some space in the above, that is what they have given the value, just you can substitute. Instead of mu g, you can do the calculation, it is not a matter. So, all the students just you can have the substitution, that is mu g is equal to mu w into 5 by 4, all right. Now, it is easy, that is 4 by 3 into 5 by 4, just you can, therefore, mu g is equal to 5 by 3, what we are having, that is the first one, it is a correct answer, very simple that you are going to assume. But one more thing what they have given, we are going to take that same time, the time taken by the light to travel through the glass is same through the water. But what they have mentioned, let us see, transfers by monochromatic light, yeah, which is having that same frequency in the first and second medium also. It is very clear these type of problems are going to be solved by getting the diagram, that is G, glass first part, W for water, and you are going to take that the thickness what they have given thickness, it is nothing but distance travelled by the light in that medium. Even they have given different thickness, but time taken by the light to travel, assume you can same. Now, you can solve the problem by getting the ratio here. Here also you will get that, you will get, right. Then finally, you will get the answer by simple calculations. It is not a big task. So, if you are going to take this observation, what happened if you have incidented the light rays at different angles? Let us see. Okay, we have discussed it has been refracted, it has been refracted ray, it is a refracted ray. All right. Now, if we are going to take that, yeah, it has been refracted through the boundary at 90 degrees, right, very good. It is a reflected ray, it is going to be, yeah, this is a total internal reflected light ray, total internal reflected light ray, right. This is the total internal reflected light ray. What happened? You have to see that. Let us go for theta 1, theta 2, theta c, yeah, total internal reflected light ray. Yes, in this case you are going to get this one, yeah, in order to get this is theta I is equal to theta c, yes, yeah, theta r is equal to 90 degrees here. In this case, just one line which is going to be making that one remarkable change, that is red line which has been identified. Now, you are going to take that first one. What happened? It is going to be less than theta I is less than theta c. Here theta I is greater than theta c. Let us assume these three cases are very important. So, in order to get the total internal reflection, you have to incident the light ray which is above the greater than critical angle, no doubt at all. And one more thing, this is the denser medium, yeah, denser, and this is the rarer. This is the denser and rarer. We are going to assume. All right. So, they are going to ask that angle of incidence is greater than or equal to critical angle, that is angle of incidence greater than or equal to than theta c. Yes, then only you will get that total internal reflection. It is very clear. Now, you can take that theta I is equal to theta c and theta I is greater than theta c. All right. Now, let us go for the problems. What they are going to ask the problems, just you can confirm. For this ray, you will get that sin theta c is equal to, you will get this one mu 2 by mu 1. This is the case what we are going to identify that. This is the case. For this one, we are going to identify where for the refracted light ray, for this ray you can take that mu 1 sin theta I is equal to mu 2 sin theta r. Very clear, we are going to get this one. So, you will find out that angle of incidence and sometimes if they have given angle of refraction, what all these things, just you will get the total internal reflection when only that angle of incidence is greater than that of critical angle, very clear. Now, if you are going to take that Yeah, what happened for the critical angle if you are going to take that temperature changes, sometimes the density of the material is going to be changes. How you can find out that? That is a separate case. Now, easily you will solve the problem by getting this condition. Yeah, this is sin theta c is equal to mu 2 by mu 1, right. Now, if you are taking that sin theta c is equal to mu 2 by mu 1, that is equal to c by v 2 by c by v 1. So, it is equal to, just we can take that v 1 by v 2. So, sin theta c is equal to v 1 by v 2. This is also one relation, we can get that. Now, you will find out easily theta c is equal to sin inverse v 1 by v 2. So, when do you get that? The theta c is going to have the relation with v 1 and v 2. If they have given that v 1 and v 2, the speed of light in the medium 1 and the speed of light in the medium 2 they have given. So, how you will find out that critical angle? It is going to be identified. Yeah, very clear. Now, easily that implies theta c is equal to sin inverse v 1 by v 2, or sometimes you can find out that theta c is equal to sin inverse, you will find out that lambda 1 by lambda 2 also. Okay, all of you can have the concept and you can solve that many problems. If you are going to look that many problems are going to be solved by this concept. Yes. So, all the students has to get the attention to utilize this best opportunity. If you are going to utilize this opportunity, you may rise in your future, you will get, surely you will get the success, 100% you will get the success in this educational career, right. So, you should have that and should have the classes and watch the classes in different social media and convey for the people. Yes, you can do the needful thing. Okay, thank you all of you. Have a nice day.